Before we actually start with the coding part, let's first explore what ingredients are needed for Retrieval-Augmented Generation system to work. As you can see here, a RAG system requires 4 different segments to work properly. Obviously, one of those segments is the large language model, which is marked here as LLM. The second model we need is the embedding model. So in addition to large language model, we usually almost always need another model, which is called the embedding model. Then we need the knowledge base. Knowledge base will essentially be documents that we provide to a RAG system. And finally, in this tutorial, we'll be using a framework which is called FAISS, or Facebook AI Similarity Search Framework. This framework will enable us to create something which is called a vector store, and this vector store will be used to perform similarity search. So FAISS will both create the vector store and also be used to perform similarity search and enable a RAG system to retrieve information more accurately. Go through first 3 steps, which are basically preparing for the whole system to work. You will see that all dependencies packages are installed. When I run the second one, it will load the packages, and we can now proceed with the other segments of the code. Now, the third step is very important. That's where you define the OpenAI API key. I won't be doing this step live because it's very important to safeguard your OpenAI API key. So you can add the key here and click run, and then proceed to the next step. Next step is defining the knowledge base. Here, it's just 2 sentences, the capitals of France and Germany, but essentially it could be very large documents that we can use as a knowledge base for the RAG system. For simplicity, let's just keep it as it is. The next step, 2 next steps are actually related to what I was discussing at the beginning of the tutorial. We need to define the embedding model and the large language model. So the embedding model will be ADA002 by OpenAI. I define it here, and the large language model will be ChatGPT 3.5 Turbo, and I define it here. Finally, to put the whole system together, I need a RAG function to actually connect all these parts into a functional system. The RAG function is now also created, and I can now run the RAG by using the code in the last cell. So you see here, I can ask a question, for example, what is the capital of France? The answer is Paris, so it used the context that we provided here and answered. I can do the same for Berlin. What is the capital of Germany? It answers Berlin. So the RAG system is working, a very simple implementation of the RAG, but very powerful because you can now fully customize it using Python programming and so on. Now let's perform one very interesting experiment, which is that how do I know that the RAG system is actually listening to what we provide in the context? So let's, for example, write here that some other French city is the capital of France, which is wrong. So I'm intentionally providing wrong context just for the experimentation purposes. So I will write, for example, Toulon is the capital of France, and rerun everything. So we have to stop the interactive loop here and then rerun the cells moving forward. And let's ask again, what is the capital of France? It answers Toulon. So even though the LLM itself probably knows that Paris is the capital of France, it's actually listening to what's in the context. You can see here that I wrote as a message, prompt message to my RAG system that it should actually answer based on the context that's there. And I also set another very important aspect here, which is temperature equals 0. So when I set those arguments, and when I set that configuration in such way, it will try to focus on the context much more than on the knowledge of the large language model itself.